welcome everyone. In this session, we have Dalila Hattab, who is the head of financial services lab with Worldline Company. Dalila will be presenting machine learning for time series forecasting. Just a quick note to attendees to please post your questions to the Q&A box instead of the chat. And Dalila, a reminder to start your timer for this 19-minute talk and to leave 4 minutes at the end for questions. So with that, off to you.
Thanks a lot, Brooke. So hello everybody. Very happy to be here and to share with you the subject and the talk of today about machine learning for time series data, for time series forecasting. So let me introduce you Worldline Company. I am from Worldline Company. So Worldline is a European market leader in payment and transaction services. With the acquisition of Ingenico, Worldline becomes the 4th largest company in the payment industry. We design and operate digital payment and transactional solutions for merchants, for bank acquirers, for financial institutions, and also for clients in various industries. So, what about the context of time series forecasting? It is really important in the time series forecasting to have an accurate time series forecasting, which is really critical for many disciplines. Forecasts are vital since they guide decisions. It could be required for short-term, long-term, or medium-term horizon. So, in the digital business today, in the digital world business today, anomaly detection is really imperative because most online companies already use data to detect anomalies on their metrics that can lead to save money or create new business opportunities. Regarding the financial market area, accurate prediction of stock market returns is a really challenging task due to the volatile nature of the financial stock market. But I will present to you how maybe this can help with machine learning to improve that. So I propose to you 2 main applications I have studied, which is the ML-based anomaly detection, and the second one in the financial market area, which is the ML-based trading strategy. Let's have a look to the data we deal with to do the forecasting that are time series. Time series data are really produced everywhere. They are characterized by many components. The first component is the trend component that can be upward or downward. The second one is the cyclic component that can be influenced by the business cycle fluctuations. The third one is the seasonal component that is influenced by the season of the year. And the remaining one is the irregular component that is considered as disturbance that affects the time series data. So how we can use it in the anomaly detection area? When you monitor your system to see if it is healthy, you track metrics and KPIs. The aim of this subject is to move from reactive behavior to predictive behavior by catching weak signals and anomalies as unexpected spikes, drops in the time series data that could prevent from issues. What we have proposed by thinking about anomaly detection engine, we have proposed this engine that is built and based on unsupervised learning. The input are the existing metrics in our process and servers, and the output are the anomalies. So the model used are suitable to highly dynamic environment with a complex and fast-moving time series data with many aggregation level, from 1 value every minute to 1 value every hour, for example. And several machine learnings are used to approximate the normal behavior of the time series data that is expected. So the anomaly is retrieved from the extreme deviation that could be detected comparing the true value of the data against the predicted one. So here play the role of forecasting method that can really model the normal behavior. So we have applied it in a typical use case here in Worldline to monitor our financial transaction generated by our platforms. And we have compared it to threshold-based anomaly detection. And we see that when we use machine learning, we can really improve the and reduce the false positive. Like you see on the top, we have the threshold-based model that generate more false positive compared to AI-based model, which is impacted by really a more accurate prediction done on the time series data. So this was the first subject. I was really pleased to share with you. The second one is regarding the forecasting on time series data, but time series that are produced by financial market. Financial market, we are dealing with prices, we are dealing with returns, prices like you see on the top right, with the returns that are considered as a ratio between the price at time D and the price the day before. That gives and generates this kind of theory. But what we can see is really a specific characteristic to these kind of theories that are called chaotic system. And I was interested to investigate how can we build a long-term investment based on ML, machine learning strategies, and to analyze this long-term investment during the COVID-19 crisis. So you can see that the market dynamic is, and its uncertainty is really measured by the volatility, is the figure given in the middle on the top. And you can see the price of the French index market with a drop during the COVID crisis, 19 crisis. The chaotic dynamic is much more seen when you when we analyze the return, which is many competing paradigm, stability period followed by sudden and dramatic change, and you can see the dramatic change at the end, which is linked to the crisis, instability, cycle of varying lengths that makes the long-term prediction mostly impossible. So I have been interested by this phenomena, and I have tried to build a model based on ML, and based also on other theories. Among them, it's the Hurst component. It's a time series property that I have used, which is a basic value of fractal analysis. It's an iteration of nonlinear equation with the past events that have significant impact on the present and the future. We can capture both long-run dependencies of the past and the short-term dependencies. How we can do that? If we look at the Hurst component, when the value is greater than 0.5, you can capture much more trend and long-term trend of your signal. And if it is lower, you capture more local irregularities. And this is really on which the Arfima model I have used is based on this component to really capture the long-term and short-term dependencies. Based on that, I have built an hybrid model based on neural network to create a forecaster model. The input are the return, the output are the return predicted for the next days. I have proposed as input both return and its expression with the Arfima model. Why I have coupled it in a hybrid way? Because I was interested to put together the different capabilities and to take benefit of each of them. Arfima can capture the structural dependencies that is more explainable regarding the host component, and the NLP that can capture unseen nonlinear dependencies and change in the return that cannot be modeled by the Arfima model. And on the top of that, the strategy built is regarding the forecasting of the model. When I forecast a return that is greater than 0, so I generate a buy order. When the return is negative, I generate a sell order. The result of that is really interesting. In this table, we have multiple models that have been compared to models based on MLP and hybrid and the Arfima model, and you can see that the MLP-based model are really much more performant in the figure, and the other one are really less performant. In the figure, I show you the investment from long-term investment starting from 2016 till the period of the crisis. And you can see that the MLP model show a real resilience to the crisis because you can see a jump just after the drop, a jump that show you that there is a resilience. The table shows many performance measures. We can use Sharpe ratio. When it's close to 2, it means that the strategy is really good. The ratio between the risk you have taken and the return and the profit you can, the benefit, the gains you have versus the risk. And the MLP-based strategies shows a real good Sharpe ratio and good profit ratio also. Compared to the other strategies, I have used as benchmark the buy and hold, which is known like you buy an asset at the beginning of your investment and you hold it in your portfolio regarding the fluctuation of the market. And you can see that the buy and hold strategy really fail during the crisis here in green color. And the naive strategy also failed and are not really sustainable. So these results have been proposed and published in lecture note in computer science. Yeah, that's it for me regarding the results and use cases that are based on forecasting with models. So I will be happy to respond to questions, if any. So the first question, it seems like the MLP model outperformed the other models, mainly in 2016. What caused it to do so well during that initial period? So if you look back to, if you look back to the diagram. Yeah, because when we start the learning we start the learning from the previous period before 2016. So the window I have used here is about 1 year window regarding the history before the 2016 and the capability to capture the different characteristic of the behavior of the market before 2016. Since the accuracy of the forecasting model was good, we were able to really maintain the return and the return after 2016. And this it's cumulative return. It means that you can have fluctuation plus and the minus every day, and if you accumulate globally, you generate a positive cumulative return starting from 0 here. Okay, and this is thanks to the good learning of the period before that enable you to maintain a good strategy regarding the what you have forecast before. This is why the MLP model gives good results. What is the XY axis? The Y axis is the percentage of the cumulative return. So it's yeah, sorry about it because we do not see really clearly graduation, but it's the cumulative return given in percentage. Would like to see how large of a difference there is between models. The difference can be seen here in the table regarding the, you can use the profit ratio that gives you at the end of the period at which profit ratio you are. And at the end of the period, we are at 43% or 40% for the MLP-based model. And for the others, we are really, we have more loss or less gain compared to the MLP one. This is the way that you can compare the both models. Other questions? What does MLP acronym stand for? Again? So it's a multiple layer perception. So it's a version, simple version of neural network. So we have 3 stages. We have input. We have 1 layer in the middle, and we have the output. So it's really the simplest configuration of the neural network. Okay, other questions?
All right. I'm keeping an eye on time, and it looks like that is the time that we have for today. Thank you so much for this talk. I really enjoyed learning more.